In this demonstration, we're going to be taking a look at calculating current flow in a series circuit when you have a couple of loads. In this circuit, we have two resistors that are in series, R1 and R2. And the first step in order to be able to solve for the total current in the series circuit is to calculate your total resistance. And I would also recommend redrawing the circuits as they become more complicated and you get more loads and larger circuits. It's going to become easier to redraw them every time. In this case, it's pretty easy. You combine R1 plus R2, and when you combine those resistances, you can redraw your circuit with your source voltage or your power source and the combined resistors R1, 2 with a total resistance of 24 ohms. Now, using Ohm's law in this case, once you find total resistance, you can find total current. The total voltage was given, and it's a source voltage of 48 volts, and we calculated the total resistance, and that's 24 ohms, and now we need to calculate the total current flow. So once again, you can just cover up what it is that you need. So if we want to calculate the total current flow, once again, is I is equal to E divided by R, or E total divided by R total. And in this case, we have a source voltage of 48 volts divided by 24 ohms. So our total current flow in this circuit is 2 amps. So for a series circuit, this is kind of an important thing. A series circuit, current is your reference. Current is unchanging at all points in this circuit. So we have this circuit with one equivalent resistor can be looked at as totals. We have 48 volts is a total voltage, 24 ohms is the total resistance, and now we have an I total that equals 2 amps. Well, in a series circuit, that current flow is the same at all points. So if we go back up to our original circuit where we have R1 and R2, R1 being 12 ohms, R2 being 12 ohms, the current flow is the same at both of those points. You have 2 amps of current flow here, and you also have 2 amps of current flow in R2.